Hello students, welcome to lesson 7 on trigonometry. I hope you are all doing well. Good. Now before we begin our lesson, let's take note of the following announcement. After watching this video, if you realize that there was a concept you did not understand, please do not hesitate to give me a call. My number is on the flyer on your screen. So pick up the number and then give me a call for further explanation and clarification. Now you can see on the screen, okay, that on the flyer I ran some online courses: core math, elective chemistry for SHS 1 to 3 and NOVDEC students. So if you are in need of these services, or if you know someone who is in need of these services, please do not hesitate to give my number to the person for him or her to call. And trust me, you will never regret. Thank you. So that was just by the way. Now let's move on to our lesson for the day. Good. So the last time we met, we looked at the trigonometric ratios. Good. So we saw that the trigonometric ratios, they are 6, but in core math we'll focus on what? The basic 3. So the first 3. So there are 6 trigonometric ratios, but we'll focus on what? 3 of them. So we saw that one is called sine, the other is called cosine, and then the third one is called what? Tangent. So we have sine, cosine, and tangent as the trig ratios. So we saw that when we want to make reference to the angle that gave out the ratios, we can have sine theta, cos theta, and tan theta based on what? Theta as our reference angle. If we are using alpha 2 as our reference angle, then it's going to be sine alpha, cos alpha, and tan alpha. So we saw that sine theta is opposite over hypotenuse, cos theta is what? Adjacent over what? Hypotenuse, and then tan theta is what? Opposite over what? Adjacent. Okay, so we said to remember the trig ratios, okay, we have to look at this acronym SOHCAHTOA. So SOHCAHTOA. So means what? Sine is opposite over hypotenuse. Ka means what? Cosine is what? Adjacent over hypotenuse. And then tan is what? Or it means what? Opposite over what? Adjacent. So we established this fact that in order to remember, you have to know SOHCAHTOA. So its sine is always the opposite over hypotenuse. Cosine is always the adjacent over hypotenuse, and tangent is what? Always the what? Opposite over what? Adjacent. Good. So I gave you an assignment. I told you to look for the trig ratios for sine alpha, cos alpha, and then tan alpha. I hope you've done it. Good. So let's look at the solution and then you compare it with yours. Right. So sine alpha. So we know that sine is always what? Opposite over what? Hypotenuse. So we move on to our diagram. So on our diagram, our reference angle is what? Alpha. So the side opposite alpha is what? Is A. Okay. So it's A. So once alpha is our reference angle, this side will be what? Our opposite. So our opposite is what? A. Then our hypotenuse is always the longest side, or the side facing the 90-degree angle. So it's going to be what? H. So sine alpha is what? A over H. Now let's move on to cos alpha. So we know that cos is always what? Adjacent over hypotenuse. So on our diagram, which side of the right angle triangle is adjacent to our reference angle alpha? Is the side labeled what? O. So this is our adjacent, and this is always our hypotenuse. So we are now going to have O over H as the ratio for what? Cos alpha. And then tan, we know tan is always opposite over what? Adjacent. So with alpha as our reference angle, our opposite is what? A, and then our adjacent is what? O. So we are going to have A, which is our opposite, over what? O. Good. So this is the solution to the assignment. Okay, this is the solution to the assignment. Good. Now we'll come back to these two ratios in our subsequent lessons. Okay, we'll come back to this particular diagram with all these three ratios again. Good. So now that we've seen, or we've known how to find the trig ratios, let's now use specific values, okay, specific values on a right angle triangle to find the trig ratios. Okay, good. Now before that, let's look at something. We learned about the properties of triangles, that in every triangle the sum of interior angles is what? 180 degrees. Okay, good. So in this triangle we have 90 plus, and then plus theta plus alpha should be equal to what? 180 degrees. I hope you are with me. Good. So if one of the angles is 90 degrees, it means that the other two angles, when we put them together, they should also give us 90 degrees. Do you agree? Good. I'm sure you agree, because 90 plus 90 will give us what? 180. So if the sum of all the three angles will give us 180 and one of the angles is 90, it means that the sum of the other two is what? 90. Is that okay? And what's the name given to two angles that sum up to 90 degrees? What's the name? Oh, have you forgotten? It's called complementary angles. So complementary angles are two angles that sum up to what? 90 degrees. So two angles that sum up to 90 degrees are complementary angles. So alpha and theta are complementary angles. Why are we saying they are complementary angles? Because when we add them together, we get what? 90 degrees. Okay, good. And you can also bear with me that they are all acute angles. So this is an acute angle, this is an acute angle. So what then is an acute angle? So we learned that acute angles are angles less than what? 90 degrees. Okay, so angles less than 90 degrees are acute angles. I hope you get it. Good. So this angle is not more than 90 degrees, it's less than 90 degrees. This one too is less than what? 90 degrees. Good. So we want to look at the trigonometric ratios of acute angles from a given right angle triangle. So let's look at that. So finding trig ratio. So trigonometry or trigonometric ratio can be shortened as trig. So finding trig ratios of acute angles from a given right-angled triangle. So when we are given a right-angled triangle and we are asked to find the trig ratios of an acute angle, how are we going to do that? Okay, so let's look at our first example. So the question is, find sine theta, cos theta, tan theta in the triangles below. So we've been given some triangles, two of them, and we have to look for the basic trig ratios in relation to the triangles. Okay, so let's quickly look at that and see how we can find the trig ratios. So with the first triangle, all the sides are given. We have the hypotenuse, we have the opposite, and then we have the adjacent. So things has been made easier for us. Things have been made easier for us. So we have all the sides given, and our reference angle, which is theta, is also what? Given. Okay, good. So with this, we quickly state what? The trig ratios. So we know that sine is what? Opposite over hypotenuse. So we put that one down and then we substitute. We know that cosine is what? Adjacent over hypotenuse. So we state that and then we substitute. And then we also know that tangent is what? Or tan theta is what? Opposite over what? Adjacent. So we state that and then we substitute. I hope you get it. Good. So now let's look at the presentation. So as I said, always write the question number. So we are referring to diagram 1 and then the I question. So we're to find sine theta. Okay, and we know that sine theta is what? Opposite over what? Hypotenuse. So from the diagram, what's the opposite and what's the hypotenuse? So let's check. So the opposite is the side facing the reference angle, which is 8, and then the hypotenuse is what? 10. Good. So we are now going to have 8 over 10. So this one can still be simplified. So we do the cancellation. 2 go here, 4. 2 go here, what? 5. So we are now going to have 4 over 5. So sine theta is what? 4 over 5. Sine theta is 4 over 5. So 2 goes here, 4. And then 2 goes here, what? 5. Good. So let's move on to II. So with II, we have to find cos theta. So cos theta is what? Adjacent over hypotenuse. So from the diagram, our adjacent is what? Is 6. And then our hypotenuse is what? Is 10. So this one too can be simplified further. Okay, 2 go here, 3 go here, 5. So we are going to have 3 over 5. So our cos theta is equal to what? 3 over 5. And then finally, III. So that one too, tan theta. And we know that tan is always what? Opposite over adjacent. So it's left with the substitution. So our opposite from the diagram is what? 8. And then our adjacent is what? 6. So now, simplifying further, 2 go here, 3 go here, what? 4. So we are going to have 4 over 3. Now we can't cancel further, so we leave it like that. So tan theta. Tan theta. Good. So this is the solution to the first one. So you can do the cancellation as well. 3 and then 5. 4 and then 3. Good. So that is the solution to the A. Okay, that is the solution to the A. Good. Now let's look at the B. So with the B, we weren't unfortunate. Sorry, we weren't fortunate. Okay, we weren't fortunate. It's unfortunate that all the sides were not given. So it's only the hypotenuse and the what? The adjacent that was given. The opposite wasn't given. So we are to find the what? The opposite. We are to find the opposite. Okay, and how do we do that? How can we get the opposite? Good, it's through Pythagoras theorem. So we can get the opposite by using what? Pythagoras theorem. So we need to use Pythagoras theorem to find the opposite so that we'll be able to get all the sides and it will be easier for us to find what? All the trig ratios. I hope you are with me. Good. So with this particular type, because all the sides were not given, we have to redraw the diagram, use Pythagoras theorem to get the other side, and then we complete the diagram before we find out the ratios. Okay, good. So let's quickly do that. Good. So that will be B. So we need to sketch the diagram. Right. So this side was giving us 2, this side was giving us 1. And then this is our theta. Okay. So from h squared is equal to o squared plus a squared. That's the Pythagoras theorem. From this diagram, our h is what? 2. So we have 2 squared. And then our opposite is what? We don't know, so let's maintain the opposite squared. And then the adjacent is what? 1. So 1 squared. Okay. So now we are going to have 2 squared minus 1 squared equals what? O squared. So we are going to have 4 minus what? 1, which is equal to O squared. So our O squared will be equal to what? 3. Then our O will be equal to what? Square root of what? 3. So it's plus or minus 3, but we are dealing with what? Distance. So we ignore the what? The negative 1. Okay, good. So our O is what? Root 3. Our O is root 3. Good. So now that we have our O, we can quickly answer the question. Okay, because all the sides are given. So now this will be what? Root 3. Okay, so I is what? Sine theta. So we know that sine theta is what? Opposite over what? Hypotenuse. So we state that one, opposite over hypotenuse from SOHCAHTOA. Then let me continue here. So substituting, we are going to have from the diagram, what's the opposite? So the opposite is root 3. So we write root 3 over, what's the hypotenuse? The hypotenuse is 2. So we write 2. So it means that sine theta is what? Root 3 over 2. I hope you get it. Good. Then II. So II is what? Cos theta. So we know from SOHCAHTOA that cos theta is what? Adjacent over hypotenuse. So from the diagram, what is our adjacent? Our adjacent is 1. So we have 1 over, what is our hypotenuse? Our hypotenuse is 2. So we have 2. So it means that cos theta is what? 1 over 2. I hope you are following. Good. Then the last one, we have to find tan theta. So we know that tan theta is what? Opposite over adjacent. Okay. Good. So from the diagram, what is the opposite? What is the adjacent? So the opposite is root 3. And then the adjacent. The adjacent is what? 1. So finally we can have root 3 as what? As our answer. So tan theta is equal to what? Root 3. Good. So I hope you followed me. Good. So when the triangle is not what? Complete, when all the sides are not given, you have to use Pythagoras theorem to find the side which is not given. Then you move on to what? Your ratios. Right. So students, we'll end our lesson for today here. Okay. We'll end it here, and you know I won't leave you without an assignment. Good. So now let's look at the assignment. Okay, let's look at the assignment. Good. So this is the assignment. Very easy, beautiful question. So read the question, look at the diagram carefully, and then just apply whatever we've learned. Okay, good. So till we meet again, keep on revising and read ahead. Bye.